Today we're going to be talking about similar triangles. So very similar to how we proved triangles congruent, today I'm going to give you the reasons why we could say triangles are similar. Okay, triangle similarity. AA similarity postulate. So if you have two angles congruent in two triangles, then your triangles are similar. And that is what we call a similarity statement. That's an E there. Okay, so if you have two angles congruent, then you could say the triangles are similar. Side, side, side similarity. Now this is different. If all three sides are proportional in one triangle to all three sides in another triangle, then your triangles are similar. And side, angle, side similarity. So we have side, angle, side. So the sides are proportional and the angle included between them are congruent, then your triangles are similar. Okay? If we ever have to do this, if you want to give a reason, all you have to put is AA and then our little similarity symbol. Side, 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 similarity. Side, angle, side, similarity. Okay? Because we want to make sure we understand the difference between this and congruence. Okay? When we were congruent, we had a side, side, side. We had a side, angle, side. And these triangles are not congruent. Okay, they're similar, so I just want to make sure you understand the differences between those notations. Okay, example 1. Determine whether the triangles are similar. If so, write a similarity statement. Explain your reasoning. Okay, so for this triangle, I need to find the third angle. So 180 minus 42 minus 58. Ooh, this angle up here is 80. That makes this angle probably down here 58. So I have my triangle similar by angle, angle, similarity. So I need to state my similarity statement. So my similarity statement, and I will highlight that again for you, is similar to triangle. So I have A, B, C, A, B, C. So I started at my 80-degree angle. A corresponds to E, so that gets listed first. Then I go down to D, which is 42, and then over to F. And again, this is your similarity statement. I'm really emphasizing this because I'm teaching geometry right now, and some of the students have messed up what a congruent statement was when we were talking about congruent statements. So now I'm really highlighting the similarity piece. Okay, this next example. I have parallel lines. Parallel lines, so if I look at this parallel line, they're cut by a transversal. So I know this angle there is congruent to that angle. I know that vertical angles are congruent. So we're similar by angle, angle, similarity. And again now, I set up one triangle similar to the other one. Okay? It doesn't matter what order. I'm going to go PQX. Is similar. Okay, but I need to make sure I get the right corresponding angle. Q is congruent to N, and that's the middle letter, so that's going to go in the middle. X is congruent to X because they were vertical angles. So therefore, M is my third angle in the other one. And again, this is my similarity statement. Okay, next one. Determine whether triangles are similar. Oh, this is a good one. Okay, so I'm going to guess, I'm looking at this triangle, and I'm going to look at the largest side. The largest side here is AB. The largest side over here is DE. So I'm going to look and see 9 over 6. That reduces to 3 over 2. I'm going to look at now the smallest side. So my smallest side in triangle ABC is 6. And that smallest side is going to correspond to 4. Reduce each of those by 2. And then I'm going to look at my middle side, 7.5 over 5. In my calculator, I'm going to do 7.5 divided by 5. And I'm going to see if I get the same proportion. So all of the sides are similar, or all the sides are proportional, I should say. So side, 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 similarity. And I'm going to say triangle A, B, C is similar to triangle. Okay, so I started with A. That side is between the largest and the smallest. So between the largest side and the smallest side. So D is my corresponding angle. I might want to mark those up. And then I went down to B. So I go down to E. And then over to C. And that makes sense that C is the corresponding angle. It's congruent to itself because of vertical angles. Okay, if so, so the next one. I actually think this is a fun one because you have one big triangle and then another small triangle. They both share this common angle of M. So they have an angle that's shared. Now what I want to see is MR proportional to MN. Well, MR is 10 plus, I think that's a 15, so that's 25 over 10. And that reduces to 5 halves. Similar, so I have a proportion for these sides of the triangle. I need to see if this other side, this MS, is going to be proportional to MP. So I start plugging in. MS is 30. So 30 over 12. That also simplifies to 5 halves. So these triangles are similar by side, angle, side, side, angle, side similarity, because my sides were proportional and the angle included between those sides was equal. So now I would need to write my similarity statement. So triangle RMS is similar to triangle. So I started with R, so I need to start with, I want to show you guys in the colors, NMP. And that makes sense because RM or MR It was similar to NP. Okay? Okay, so we've tackled that. Now we got some algebra happening. So I'm given that RS is parallel to TU. RS is 4, they have that labeled for me. RQ is x plus 3. QT is 2x plus 10, and UT is 10. Find RQ and QT. Okay, so let's see if these triangles are similar. I have parallel lines. I have a transversal, so angle T is equal to angle R. I have vertical angles congruent. So I know triangle RSQ is similar to triangle TUQ. So I need to set up a proportion. So TU or UT is proportional to RS. So RS over TU is equal to, is QT, and RQ are also proportional. I started with this smaller triangle, so RSQ. So RQ is corresponding to QT. Now we plug in. RS is 4. TU is 10. RQ is x plus 3. QT, 2x plus 10. I cross multiply. And I simplify. 8x plus 40 is equal to 10x plus 30. I subtract the 8 over, so I get a 2x. Subtract the 30 over, so I get a 10. X equals 5. So what I wanted to make sure that I found is I'm answering the question. You're not just solving for X, you're answering the question. So RQ is x plus 3, which is 5 plus 3, which is 8. QT is 2x plus 10, so 2 times 5 plus 10, that's going to be 20. Okay, skyscrapers. Josh wanted to measure the height of the Sears Tower in Chicago. They've actually, since this example, they changed the name of the Sears Tower. I can't remember if I just kept it the Sears Tower. If you don't know, I am from Chicago and I will always call it the Sears Tower. He used a 12-foot light pole and measured its shadow at 1 p.m. The length of the shadow was 2 feet. Then he measured the length of the Sears Tower shadow, and it was 242 feet. At the same time, what is the height of the Sears Tower? Okay, so let's look at this. So here's my sun. Look at that sun. Okay, so I have, I'm going to call it Sears Tower. And it is perpendicular to the ground and is casting a shadow. If you think about it, the sun's up here, so it's casting its shadow there. And then he used a 12-foot light pole. So I'm going to say LP for a light pole, casting a shadow. Okay, so why are these triangles similar? We have a right angle, because hopefully the light pole and Sears Tower are perpendicular to the ground. Now the angle that the sun makes here is congruent to this angle there, because it's what we call the angle of depression-ish. But these angles are going to be equal. Also, the shadow lengths are going to be similar, or going to be equal. They're technically proportional, I should say. Okay, ST, that's Sears Tower length. That's what I'm looking for. He used a 12-foot light pole, so that's 12. The length of the shadow was 2 feet. He measured the length, and it was 242 feet. So X is to 12. X is to 12. So X is to the length of my Sears Tower is to my light pole. As the shadow of the Sears Tower, because I started with the big one, 242 is to 2. So 2X is equal to 2904. I solve for X and I get 1452 feet. I actually wonder how accurate that is to the height of the Sears Tower. Okay. Thank you for watching my video on similar triangles.